So again, we are doing remote asynchronous, so you're not required to stay. But I do just need you to check in. Let me let this load all the way. All right, and I gotta stop that. Let me share my screen. Let's hit done. Okay, I'm just gonna get this student. Hit save. Come on, attendance. This one. Today. Come on. Boom. All right, and edit. So, and let me go ahead and share my screen. It's gonna be cool. All right. I'm assuming that everything is working. I haven't noticed anything different. I'm gonna click someone else. I guess someone's to close it. So today I would like to continue talking about section 2.5. I am aware that some students have gotten ahead again. That was the whole intent of the way I designed the course. So this is like the end of week 2, right? Let me see, exam 1, we can anticipate exam 1 to become available on Pearson. I think it's in week 4. I think I put you guys exams during week 4, 8, 12, or maybe 4, 8, 13, something like that. But you'll see them. Look at the student who's just coming in. Let's see. Fletcher and Thompson. Fletcher. Hit save so I don't lose my work. Record. Come on. This one. Okay. I totally lost my train of thought. Let me think about it. Again, this is remote asynchronous. So all the homework assignments that I wanted you to work on throughout the semester, I've already loaded. All the quizzes that I want you to work on throughout the semester are already loaded. You have access to all these assignments are available, and you have access to all of your homework and quizzes for the semester. So the only thing that you're waiting on outside of those two are our exams. Again, the exams are going to be available you can anticipate them being available during week 4, week 8, and I think it's week 13. Usually I would have done week 12, but because of like spring break, that pushed the stuff after that back by a week. Let's hop back over here. Let's see if there's anything else. Yeah, and today I just wanted to kind of continue with section 2.5. Also, I highly encourage everybody. I think this class has a group meet, so hopefully you're a part of that group meet. I do encourage you all to work together. It's totally fine. And then the other thing is I highly encourage everybody to connect with the tutors that you've already paid for. The tutoring service is a part of your Morehouse tuition. So a lot of times the tutors are just sitting there waiting for students to come and ask questions. I encourage you to take this material, and you can sit down with the tutors and either go through the recordings or go through the homework. They're just sitting there waiting for you guys to ask questions. So with this being remote, you can be anywhere. Y'all could even have class with the tutors if they let you. And like, you can ask them directly, like in person, about some of the things that I say, right? Or that I share. Again, I'm by no means like an end all be all. I'm just a guide. I'm just here kind of like a facilitator. I just lay the field, set everything up and turn you guys loose. And all I do on my end, I just write down what you guys are doing. I don't really do anything outside of that, right? So, at the end of the day, it's all on you. All right, Mike, let me see. Go ahead. Let me see. Is that? Shoot. Let me see if that's who I just let in. Yeah, okay, cool. Let's save them. And again, if anything is not clear, feel free to go ahead and unmute yourself, ask questions, stop me, because if you don't stop me, I'm going to assume that you get it, and I'm going to just keep plugging and chugging. Okay, so I'm just setting this thing back up. And let's go ahead and hop over to Pearson and kind of continue where we left off from last time. I can let that stay. So last time when we were working through the homework, we made it through question 8. So today we're going to start on question 9, and describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function, right? So this is a recap on transformations. Now with this one in particular, in this form, we can't really see the transformations, right? It's not in the proper form. So what we're going to do here is go ahead and do the long division, either polynomial. In this case, we can do synthetic, so I'm probably going to do synthetic division. I'll go ahead and do that division, and then once we do the division, it'll be in a form where we can see the transformations, right? So let me get a copy. Come on. I want it from, I really just need this. Let me get a copy of this. We're going to take that and drop it here. Let's see if I can at least hear it here. Okay, cool. This guy, this guy. So we want to do, now we could do polynomial long division. If you want to see that, just let me know and I'll show that one, but I'm gonna go ahead and start with synthetic division, right? The reason we can do synthetic division is because we're dividing by a linear binomial, right? Binomial because it's two terms, linear because the highest exponent is a one, right? There's an implied one here. So because we're divided by a linear binomial, we can do synthetic division. So when we do synthetic division, if we're dividing by x plus 2, the 0 there is going to be -2. So we're going to put -2 inside our chair, right? Then what we need are the coefficients for each degree, for each term from the numerator. So in this case, it's just going to be -3 and -5, right? So then when we do synthetic division, the first term just comes down, right? So then this comes down. On the diagonal, we multiply. So -2 times -3 is a +6. And vertically, we add, right? So -5 plus 6 is a +1. That's our remainder, right? So at this stage, if our remainder is a 1, I'm going to kind of switch the order a little bit. So that remainder of 1 goes over our original, I think it's called the divisor. I forget, I mix up the names. But that 1 goes over our original denominator of x plus 2, right? And then we say -3. So I kind of changed the order a little bit. So this is our g of x. So then in this form, now we can see our transformations. Now it's clear that if we work our way from the inside, we added a +2 inside the basic function of 1/x, and then we subtracted a 3 on the outside of our function, right? So adding a 2 inside the basic function is going to move it to the left 2 units, and subtracting 3 on the outside moves it down by 3. So transformations are not trivial, in my opinion, or they are kind of simple. It's just, it definitely is information overload, right? So you just want to recap. We said we went left, so the horizontal, we said we went left 2 units. So we went left 2 units, okay, check. And then we said we went down 3, check. Whoever this is, we're gonna let them in. Next question, okay. So again, if anything is not clear there, again, information is just one of those things. Save. Oh, did he disappear? So yeah, transformations, it's just one of those things. Like, when I was a student, I never took college algebra, so I wasn't aware of it. I was like, what's going on? I wish I had at least known about it. Like I hadn't taken the class where we had talked about it. I wasn't even aware of those things. I didn't become aware of like those techniques from college algebra until I taught college algebra. I knew how to do the math and the algebra, but there were some hidden techniques that I just was not aware of that I think kind of got in my way. But it's okay. We're here. It is what it is. We're here now. And we keep it moving, right? We just learn from these experiences and keep going. Okay, here we're asked to find the vertical asymptote, if any, of the graph, right? Okay, so the vertical asymptote is going to occur at any x that makes the denominator 0, provided that x does not make it 0 over 0. If you plug that x in and it makes it 0 over 0, that's not a vertical asymptote. It's going to be a hole in the graph, right? So in this case, when x is -4, it makes 0 in the denominator, so we'll get some number over 0. So then that means that's going to be our vertical asymptote. right? Oh, okay, I'm gonna try the script thing. So we said -4. -4. I don't know why that's not working. Let me try one more time. Okay. Let me just type that. So the iPad had something called Scribble, but I couldn't get it to work. That's okay. Typing equation. So that should be x equals -4. Okay. Let's go with that. And again, if anything is not clear, you just have to stop me. Else I'll just keep going. Find the vertical asymptotes. Okay, let me get a copy of this one. Let's take some notes. You can't just look at this one. Maybe you can, but I'm going to write it out. Let's go here. Maybe we can take this. This is one. Right here. Yeah, right there. Come on. I'm not adding this. I didn't even want to do that. Okay. Correct. Go back. Okay. So the vertical asymptotes, right? So here, it's a good idea to go ahead and just write, basically factor the numerator and the denominator, right? So if we start with the numerator, so this is a special factoring scenario. Sorry, some noise over here. I'm got a load of clothes on. If we start with the numerator, this is a special factoring scenario, right? This is called difference of squares, right? We have something squared minus something squared. So then this is going to factor into x minus 5 times x plus 5, right? So that is a special factoring scenario. Now, in the denominator, we want to see, can we factor that trinomial into something of this form, where we have x and x? Can anybody tell me, based on this red circle, can you tell, what does this tell us about the signs, our signs, right? If this is minus, and we want two things that multiply to give us minus, a negative, what does that tell us about our signs? They have to be what? Because this is minus, our two signs have to be opposite, right? One has to be positive, one has to be negative, right? So that way when they multiply, they'll give us a negative, okay? And then this one tells us the sign of the larger number, right? So the larger number is going to be positive. So now we're looking for two numbers that multiply to give us -54 and add to give us +3. 54 here. Okay, so let me do this. So 54 is what? Is it 9 times 6? 9. So 6 is 2 times 3. 9 is 3 times 3, right? So I'm pretty sure you can see the result already, but I just want to kind of walk you through this. If you're like, I just want to walk you through this. So what I'm going to do is list out all the factors of -54 and stop at the line that adds up to 3, right? So first we have -1 and 54, but this adds up to 53, so we're going to keep going. We can do 2. So watch, if we do 2, what's left over? 27, right? So if we use this 2 already, notice we have 27 left over. Right? So then 27 plus -2 is 25. So those are not the 2. Okay. 3, we can do 3. Notice if we do a 3, what's left over? 9 times 2 is 18. So we have 18, those add up to 15. So these are not the 2. We're going to keep going. Can we do 4? No. We can't do a 4. There's no 4 in this list. We can't do 5. We can do a 6. There's a 6 right there, right? So we can do 6. Now, if we do this 6, what's left over? 9, right? And I'm pretty sure you got those numbers earlier, but that's okay. I just wanted you to see this process. Notice that 9 times -6 is our -54. 9 plus -6 is a +3. So these are the two numbers that we were looking for. And then we'll go ahead and include them. We said it's a +9, -6. Notice the larger number is positive, right? So now in this form, now that we have it in completely factored form, we can clearly see all the components that we need. Now we can see that the vertical asymptotes are going to occur when x is equal to what? -9 and 6, right? And notice that neither of these creates a 0 in the numerator. So both of these are vertical asymptotes. So we're going to go with this. This box in my final answer style. Okay. And let's hop back over to Pearson. Okay. Simplify, type in equation, use comma, separate as needed. Okay. So what, we got -9 and 6, so then x equals -9, comma, x equals 6. Okay, hit enter. Okay. Again, if anything is not clear, stop me. Hopefully everybody's okay. We got about solid, a little over 25 minutes, so we're gonna kind of keep moving and grooving. Hopefully we're all aboard and we're not all bored. Here we're asked to find a vertical asymptote with any of the graph, right? So now notice if we set this denominator equal to 0, I'm just gonna kind of try to zoom in. If we set this denominator equal to 0, right? If you think about this graph by itself, we have x squared plus 8. X squared is just a parabola. If you think about x squared by itself, it's just a U-shaped graph where the vertex is at the origin. If we add 8 on the outside of x squared, that's going to move this U-shaped graph up 8 units, right? So then if we're trying to find the 0, what x values make this 0? And we've had this parabola moved up 8 units. Notice the 0, it never becomes 0. Or in other words, it never crosses the x-axis. We had a U-shaped graph, we moved it up, it never crosses the x-axis. So because that U-shaped curve never crosses the x-axis, there's no x to throw out here, right? So there are no vertical asymptotes, all right? It's going to be B. Something real quick, see if you guys are still there. Okay, we got people hanging strong. We're gonna keep it rolling. Let's see, on the horizontal. Okay, so now hopefully by now you've at least found my lectures. I mean, I don't make those lectures for no reason. You definitely want to like go through them. And I do get that students generally don't, but I did explain how to do horizontal asymptotes in the lectures, right? So just be careful about skipping those. You definitely want to sit down and take notes, take your time. If you skip them, eventually what's going to happen is you're going to have a hole or a gap or a break. Didn't mean to say it that way, but you're gonna miss something important, right? That's usually what creates a lot of anxiety in people, is because math is so like particular, and it's like really to really get math, you have to slow down, right? And in this age of like, technology being the way it is, it's like I don't even know what the next level beyond the microwave generation, but a lot of people don't have that patience. They don't know how to slow down. And so you have to like slow down and take your time and go line by line. And it takes time. And like, so if you don't give yourself time, i.e. like if you procrastinate, which I definitely struggle with, what generally happens is you don't have enough time to go through it the way it needs to be gone through. So you just have to slow down, like start early. You don't have to, I mean, it just takes time. You have to start early, and that way you can go slow and take your time and go line by line. Yeah, that's what I wanted to say on that. So now with this horizontal asymptote, right? There's a three-pronged test that we have to kind of ask ourselves when trying to find the horizontal asymptote, right? So basically, the horizontal asymptote, we're comparing the degree of the numerator to the degree of the denominator, right? If we look at this numerator, the degree of the numerator in this case is going to be 1. I know I started that poll. I didn't even check that poll in the sliding. The degree of the numerator is going to be 1, right? The degree of the denominator, right? The degree being the highest exponent on any variable, the degree of the denominator is going to be 2. So one of those tests says that if the degree of the numerator is less than the degree of the denominator, then y equals 0 is going to be your horizontal asymptote. Or in other words, the x-axis is going to be your horizontal asymptote. So that's what this one is. All right. So this horizontal asymptote is going to be the x-axis. So it's going to be y equals 0. Y equals 0. Hit enter. Okay. Hopefully that was okay. Let's go on to the next question. Again, you have to stop me if anything is not clear. If we need to go back. Find the horizontal asymptote again. So for horizontal asymptote, we're comparing the degree of the numerator to the degree of the denominator. So now this is another one of those three cases. So we saw the previous one is where the degree of the numerator was less than the degree of the denominator. This is another case where the degree of the numerator is equal to the degree of the denominator. When the degree of the numerator is equal to the degree of the denominator, your horizontal asymptote is going to be the ratio of your leading coefficients. All right. Let's say that one more time. When the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is going to be the ratio of the leading coefficients. So in this case, y is going to equal, the horizontal asymptote is going to be y equals negative 8 over 5. Negative 8 over 5. Y equals negative 8 over 5. I'm going to come up here. Negative 8 over 5. Okay, so these are concept questions. These aren't really any calculations. These are, did you go through the material? Do you understand the concept? Determine the horizontal asymptote. Okay. So again, and this is the third case, right? So the first case was where the degree of the numerator was less than the degree of the denominator. The second case was where the degree of the numerator is equal to the degree of the denominator. And this is the third case. This is essentially the third case. So the third case is where the degree of the numerator is larger than or greater than the degree of the denominator. So in terms of horizontal asymptote, because the degree of the numerator is larger than the degree of the denominator, we say that there is no horizontal asymptote. There's no horizontal asymptote, right? Again, just checking, do you know the definition or the concept? Okay. So then this will ask the graph, right? So we have the reciprocal function 1 over x, and notice we added a +4 inside the base function. So if we add 4 inside the base function, that's going to move our graph horizontally to the left by 4 units, right? So all we have is a reciprocal function that's moved left by 4 units. If you think about the vertical asymptote here, right? Think about the vertical asymptote. The vertical asymptote, normally, if it was just 1 over x, the vertical asymptote would be the y-axis, right? But what you see here, x equals -4 is going to be your vertical asymptote. So that's why we moved it to the left 4, right? It's whenever you're doing inside manipulations, it's generally like the reverse of your intuition. So all this is the reciprocal function that's been moved left 4 units. And I think the only one that's been moved left 4 units, I think A went up. C and D are the wrong form. So then the only one that's left is B. I'm just going to go with B, check. Now, even if you didn't know that, you have access to graphing utilities, so you could graph it, look at it, compare, do a similar window, and then, you can just match them up that way as well. That's totally okay for now. Find the graph. Let me think about this one. Now, I could verify some points. One thing right off the rip, if we look at this denominator, right? If we think in terms of vertical asymptotes and horizontal asymptotes, the vertical asymptotes, right? We have x squared minus 16. Again, that's difference of squares. We have something squared minus something squared. So that factors into x minus 4 times x plus 4. So notice those 4s, the plus and minus 4, both of those are going to be vertical asymptotes, right? Because they're going to give some number over 0. So we have vertical asymptotes of plus and minus 4. And then if we want to consider the horizontal asymptote, notice the degree of the numerator is equal to the degree of the denominator. So then the horizontal asymptote is going to be the ratio of the leading coefficients. In other words, The horizontal asymptote in this case is going to be y equals 1. So we have vertical asymptotes of plus or minus 4, horizontal asymptote of y equals 1. So then with that information alone, I think the only one y equals 1, there it is. So then it should be B, all right? I was trying to find the horizontal asymptote. It looks like C, the horizontal asymptote, is too low, right? I was trying to find out which one was moved up by 1. So then that one would be B. I'm gonna go with B, and let's check, see what happens. Okay. So I just did that one based on the asymptotes. A little over 10 minutes remaining. Let's keep going. So if there's a six-step procedure to graph this rational function, not a reciprocal function. Don't want to take the time. I don't really want to take the time. Let's kind of pick apart some pieces, right? Let's see what it says. I don't know if I can mention that's correct. It's gonna be. Let's pick apart some of the pieces, right? So one thing, we have this x minus 3, right? So that means we have a vertical asymptote at what? X equals 3. Should be one of our vertical, should be a vertical asymptote. We can also identify x and y intercepts. For instance, the y-intercept, if we set x to 0, is going to be the origin. So the x-intercept should be something similar, right? So this should at least pass to the origin. It should have a vertical asymptote of x equals 3, horizontal asymptote of y equals 5, right? Because again, I got y equals 5 because the degree of the numerator is equal to the degree of the denominator. So now we take the ratio of the leading coefficients. That's going to give us 5 over 1, so it's going to be 5. Now let's put all those together. So I think all of these graphs pass through the origin, so we can't use that. Vertical asymptote of x equals 3. It looks like A does that. Is not B. Is not C. And it could be D. So it's either A or D. And then we had a horizontal asymptote of y equals 5. And I think the only one that has a horizontal asymptote of y equals 5 between A and D is A, right? So I did that one based on intercepts and asymptotes. I'm going to go with A. A, and let's check. Like right at 10 minutes. Let's go on to the next question. So 10 minutes, and then you can enjoy your weekend. Use the 7-step method described in the book to graph the following rational. Okay, determine the symmetry, right? Let's do a test for symmetry. Okay, this is good. Let me get a copy. First thing we want to do is a test for symmetry. Space, so I'm just kind of come here. So, and this comes from, this is question number 19. This comes from section 2.5, question 55. This is question number, this comes from 2.5, question 55 from the text. We'll add the graph here. So then the first thing we're going to talk about is the symmetry. And color. The symmetry, right? So to do a test for symmetry, in this case, what we're going to do, we're going to consider f of negative x. We're going to replace each x with negative x. So f of, we're going to replace each x with negative x. So we got x squared. So the first thing I'm doing is replacing each x with a blank set of parentheses, right? And then what goes into the blank parentheses, we're going to replace each x with negative x. So then if we do this, negative x squared becomes positive x squared, so that becomes a positive 4x squared. Same thing on bottom. Is this the original? This is the original, right? 4x squared over x squared minus 4. So then whenever we have f of negative x equals f of x, that is the that means that this function is even. That's the definition of a function being even, which is synonymous. I'm just going to write it like this. Even, which is synonymous with y-axis symmetry. So again, because f of negative x equals f of x, that's the definition of a function being even, which means we have y-axis. Let's hop back over to Pearson's and answer this question. So the graph has neither, it's not A or the first one. The graph of f is B. Okay, so it's the second one, right? Let's go to check. On to the next part. Find the y-intercept. So for the y-intercept, we set x to 0, right? So notice here, if we set x to 0, the top is going to be 0, the bottom is going to be -4. 0 over some number, that's okay. Let me share this real quick. For the second part, we were asked to find, I'm gonna just say intercepts. So I just want to kind of give you this. Whenever we have 0 over some number, this is okay. Okay. All right, so this is going to be equal to 0. But if we have some number over 0, that's a KO. You want to knock that out. So this is going to be undefined. Okay, and let me kind of do this to kind of drive the point home a little bit further. Zero over some number, that's okay. That's going to be equal to 0. But some number over 0, that's a KO. I want to knock that out, so that's undefined. Okay. So in our example, the y-intercept, when x is 0, we got 0 over some number, so the y-intercept is 0. 0. X-intercept, we set y equal to 0, but a fraction is only 0 when the numerator is 0. So I think it's, basically it's the origin, so it's going to be the same thing again. Find the vertical asymptotes, right? So the vertical asymptotes, again, this is a special factoring scenario. We got a solid 5 minutes. Special factoring scenario, we got something squared minus something squared. So the denominator factors into x minus 2 times x plus 2. So that means plus or minus 2 are going to be a vertical asymptote. And notice that these do not give a 0 over 0. 0 over 0 is a whole. I mean, 0 over 0 is a hole in the graph. It's not a vertical asymptote. But this case, plus or minus 2 is what we got. So x equals -2, comma 2, right? Horizontal, right? So the horizontal, we compare the degree of the numerator to the degree of the denominator. The degree of the numerator is 2, the degree of the denominator is 2. So then they're equal. So when the degrees are equal, we take the ratio of the leading coefficients. This is going to be 4 over 1 in this case. Ultimately, that's just going to be 4. So it's going to be y equals 4. So let's see, when x is -4, I don't feel like doing all of these. Okay, I'm going to do the following. Let's see if I can work. Here it is. This one. Choose the file. I think this is it, and I think it's this. Update it and organize that thing. So now, then what I want to do, I just want to pull this over to the side. Look at God. I don't even know if you guys are still there. I'm just like yammering. Okay, so plot some points, right? So it's now again, obviously I could have. This is fine. Yeah. I didn't feel like writing all that out, so I decided, okay, I'm just going to use. I could have done this in Excel, but I have this virtual calculator, so we can at least see it, and I'm going to use my graphic calculator, right? So I'm going to go to my y equals, and then for my numerator, I have what 4. That's not a 4. 4x squared, right? Divided by my denominator is x squared minus 4, right? I just typed it in. I just put my whole numerator in a set of parentheses, so it isolates that, it keeps it together, divided by my entire denominator in a set of parentheses, right? So then I'm going to quit. So I'm going to hit second mode to quit. Now I'm going to call on that function that I just typed in. So now on the right-hand side of the calculator, you see a button that says clear. To the left of the clear button is a button that says VARS. I think it stands for variables. I'm going to click on that button. I'm going to go to the right. My headphones are about to die. I think we're going to make it go. I'm going to go to the right to go to Y variables. I'm going to click on number 1 for function. And I'm going to click on number 1 again. That's going to call on the function I just typed in, right? So now we have this Y1. That's calling on the function I just typed in. So now I want to evaluate when x is -4. So I'm going to do parentheses and I'm going to put -4, right? What this is doing, this is kind of like saying, basically taking that function and plugging each x value into the function, and it's going to, when I hit enter, it gives me this. Let me see how it wants it. Type an integer or simplified fraction. So what I'm going to do, I'm going to just recall that. I'm going to go to math and hit number 1 for fraction. Simplified fraction. Let's think about this. Okay, I think 16/3 might work. So now it's just a matter of a question of the proper form. So the first one, I'm just going to put in 16/3, right? Let's break it down a little bit to give us some. When x is -3, right? Over here on the calculator, I'm going to hit second enter to recall what I typed in before. And I'm just going to change the 4 to a 3. Now we got 36/5. So I'm just going to type in 36/5. Okay. The next one, we got a -1/2. Let's close this out. I'm going to recall, and I'm going to hit insert. So second delete, so I can turn it to insert. And I'm going to put in -1 over. Okay, I'm right. I'm going to hit enter. We got a -4/15. I'm going to do -4/15. Cool. Now we're going to recall. Matter of fact, I'm just going to go back to the one that was the -3 and just remove the negative. No. So now when x is 3, we get 36/5. So I'm just going to type 36/5, which would be it. And then when x is 4, I'm just going to recall, put in my 4, 16/3. So I got to do like this, like this. 16. Oh, no, I didn't even use the symmetry, right? So I think we said it had what, y-axis symmetry. So whenever we get a point on the left, we automatically get a point on the right. So when x was -4, that also gave us the point when x was 4. When x was -3, that also gave us the y value when x was +3, right? So we chose a few additional points between the x-intercept and the vertical asymptotes, right? We just chose a few additional points. I'm gonna check the answer. And I know I'm trying to get you guys out of here. Let's see. Let's go. So I'm gonna get rid of the calculator for now. For the first part, we had y-axis symmetry, and it passes through the origin. And then we have vertical asymptotes of plus or minus 2. So for instance, it cannot be C because those vertical asymptotes were off, and it can still be it can still be either A or B because they both pass through the origin, and it looks like they have the proper vertical asymptotes. Horizontal, we got a horizontal asymptote of y equals 4. So then with that, it has to be A. So I just kind of took the pieces that we had and did the process of elimination. Okay. And on that note, I wanted to let you guys out 2 minutes ago, a little over 2 minutes, maybe 2.5. But on that note, we're going to end this session here. If there aren't any questions, and from one beautiful mind to another, enjoy the rest of your day. Have a good weekend, and I'll see you all again this upcoming Wednesday. All right, guys, take care. Peace.
Thank you.
And make this, share this, let me share this with you. I'll do it in just